Hello, this video is the continuation of the Cloud Native Ninja series. Today we are going to see how to containerize Spring Boot applications. So let's get started. So far in this series, we have seen how to build application using TechTalk Producer and TechTalk Consumer with .NET Core as a programming language. I also wanted to show as part of this series how to use polyglot programming for building microservices. And as part of that, I want to build a microservice which is built using Spring Boot, which is one of the commonly used framework for Java. And along with Spring Boot, I also want to show or showcase how to use Dapr, which is a distributed application runtime for building portable microservices. So if you don't know about Dapr, in the earlier part of this series, I've done a video on how to use Dapr with .NET Core, which talks about the different components of Dapr and how Dapr helps us to build portable code. So have a look at that. We are going to jump straight into this implementation and see how to incorporate Dapr with a Spring Boot application. And then we are also going to see how to containerize that Spring Boot application. So if you don't know how to get started with Spring Boot application, you can head over to start.spring.io, which gives us a Spring initializer, and we can configure a project using different configuration options. Like we can choose programming language from Java, Kotlin or Groovy. We can choose the build system like Gradle or Maven. We can also choose which Spring Boot version we want to use. So I've already done this part and I've created two projects. So let me head over to Visual Studio Code and look at the first one, which is the TechTalks Producer. This is the POM file, which talks about all the dependencies which are required for building my application. So I start with the Spring Boot Starter Web, which gives us the bare bone components for creating RESTful APIs in Spring Boot. I also have dependency on the Dapr SDK, which will allow us to interact with Dapr using Java code and the Spring Boot application. I also have other dependency, which is to the Dapr SDK Spring Boot, which again gives a better integration with Dapr and Spring Boot. And then I have other things like the Faker, OKHTTP, and the OpenAPI documentation related dependencies. So let's look at what our controller is doing. The controller is the producer of messages. So we start with the regular request mapping and the REST controller annotations for our TechTalks Producer controller. And we have one method called produce messages, which will be mapped to the generate endpoint on our REST API. This takes a parameter in the number of messages, or named as number of messages, which is how many messages we want to generate. And then we use the Dapr client and we iterate over the number of messages, and we create a small collection here with some values related to the TechTalk name, category, level, ID. So we are basically building the domain object of TechTalk, and then we publish that payload onto the RabbitMQ using the Dapr client. This is what is abstracting us from creating the infrastructure level code to communicate with RabbitMQ. All we need to do is to have a PubSub component of the type of Dapr, which is one of the components, and then we put that name here. The PubSub name is configured as RabbitMQ PubSub, and on that PubSub or on that RabbitMQ, we are targeting a topic named as TechTalk, and then we specify the actual payload, which is the details about the TechTalk that we want to publish. On the consumer side of things, the code is almost similar. So we can look at first the POM of the consumer. So it is also generated using the Spring initializer that I showed earlier, and we have almost same type of dependency starting with the Spring Boot Starter Web. We reference the Dapr SDK, the Spring Boot SDK, and the test. So on the consumer side, the number of dependencies are smaller compared to the producer. Let's look at the code of the TechTalks consumer. So here we are in the controller for the consumer, and we decorate it or we annotate it with the REST controller again. We import the Dapr topic and cloud events. So in the earlier video where I talked about Dapr, I had also talked about Cloud Event, which is a standard for publishing events, and it tries to standardize the way we work with event-driven systems. So we are using Cloud Events, which is the way Dapr wraps its events into the format. And in our consumer message, or the method which consumes the messages, we have this decoration called as topic, or annotation called as topic, which allows us to subscribe using Dapr. Again, the thing that we subscribe to is a PubSub component which we have configured, named as RabbitMQ PubSub, and the name of the topic which we want to subscribe to is the Tech Talks. And on the consumer side, what we get is a cloud event, and we then get the data for that cloud event. We map it to the Tech Talk, and then we just log the details here to show how the Tech Talks is being consumed, or what are the details that we received as part of the Tech Talk. So with that, let's switch over to the terminal and see how to build this application and how to containerize it. So the first thing we do is when we want to build a Java application, we can use the Maven command. So I'm using the Maven clean package here to build the application. So there we have the build completed, and it is a success. Once we have the build successful, we can then start to look at containerizing this application. I will not do the same thing for the consumer because the steps are exactly the same. So assuming that we have both the producer and consumer code which we are able to build, let's see what do we need to start containerizing this application. I'm going to use what is called as the multi-stage container builds, and the first thing we need for a multi-stage build is a Docker file. When we want to start to containerize our own application, we start with the Docker file, which contains the list of steps how we build our application. The purpose of having a multi-stage build is to separate the build and the run part of the application. So we use the same Docker file, but we have different stages in the Docker file for building the application, where we use a JDK image. And in this case, we are using a Eclipse Temurin based image. So this is the image which is available on Docker Hub. Eclipse Temurin is again open source Java SE build based on OpenJDK, and it's available for a wide range of platforms. And Eclipse Temurin provides the images for Docker, so like the base image for building applications. We have the JRE image, which is used for running the application, and there is also a JDK image for Java 17. And there are different tags because these are multi-architectured images, so we can run them on Windows, Linux, and various different flavors of Linux. So I'm going to use this tag, which is the 17 JDK, and I'm going to use the Alpine version of that because the Alpine based images, they are very small in size. So we start with using this as our base image, and we define the first stage as the build, and then we copy some of the things which are required for building our application. So this particular Docker file resides in my folder which is related to the Tech Talks producer, where I have the folder hierarchy or folder structure along with the pom.xml and the mavenw wrapper. I create a new file called as the Docker file for my producer or the application that I want to containerize. Then I copy these files. So these are the instructions in our Docker file which tells what steps has to be taken in order to build my application. So I copy pom.xml into this working directory called as app. I also copy the Maven wrapper and .mvn file. into this. Then we copy the actual source code of the application. And in a normal scenario, once we copy the source code, we would run the Maven package using Maven wrapper, and we would skip the test to reduce some time. If you have seen some of my earlier videos, I talked about how to use a feature called as the mount cache with Docker to optimize the build. Especially we want to cache the dependencies. When we use multi-stage build, it is going to pull the dependencies every time. It is good for having a repeatable build, a consistent build, but in terms of the amount of time it takes to pull all the dependencies, it can be very huge. So what we will see is, in the first step, we will mount this, or we will cache these dependencies for the producer, and then we will reuse those dependencies because we are using the same ID to cache the dependencies, and we reference that dependency cache or the Maven cache. So the second time when we run the build or any other builds which uses the same dependencies, we don't have to pull them again. That is the optimization we are going to do using this mount cache. So I did a video earlier in this on this channel. You can go and have a look at that video to understand how mount cache works. So I'm going to use that optimization, and once we have built the image or once we have built the application, the artifact needs to be copied to a second image. So the first image that we use is the JDK image, which contains all the build tools, but when we deploy the application to the target environment, we don't need all the build tools. We need only the Java runtime environment or JRE. So we are using a different image here, and we create the second stage of our multi-stage build process, which is for running the application or creating an image which will be used for running the application. In this case, we copy the output from the build stage and we rename the snapshot jar for the producer to techtalksproducer.jar, and we also expose the 8080 port here, and we specify the entry point, which is the starting binary. When the container instance is created, what should happen. So we are basically calling the TechTalks producer jar here. The steps are exactly the same for consumer. Only difference is that the name of the jar is different. Otherwise, all the other steps, they remain the same. So I'm not going to repeat, or I'm not going to show the consumer part. You can have a look at the code which will be published on the GitHub repository. So let's go and build this particular Docker image. So we build the application initially. Now we are going to build the Docker image. So let's first check what are the different images I have currently on my laptop. If I run the Docker images command, we can see that there are only 3 images which are used by Dapper, and I don't have any image related to my application currently. So if I do a ls here, we will see that there is a file, Docker file, in my TechTalks producer folder. I'm going to use that to build the producer. So let me run this command, docker build, and I'm going to use the tag as Nilesh Kule TechTalks producer, and Java as the tag for the image, TechTalks producer image, and I pass the context, current context, to the Docker build. Now watch the time, or the amount of time that is taken to build this particular TechTalks producer image. The reason I am saying this is I'm expecting the dependencies that we have specified in our pom.xml to be all pulled fresh for this build, because this is running as part of a multi-stage build and it doesn't reference the Maven cache on my local machine. This particular Docker build is going to pull all the dependencies fresh from the Maven Central. So let's say how much time it takes to build the TechTalks producer, and in the next step we are going to use Docker Compose to build both the producer and the consumer images. So let me switch over while this is building to the Visual Studio Code, and let's look at the file which is the Docker Compose for this. So Docker Compose allows us to build and publish and run multiple images. It is very helpful when we are having a multi-container based application and we want to start and stop these multiple containers in one go. So for my TechTalks consumer and producer or TechTalks application, I have two services, the producer and consumer. And here we specify what should be the image when it is built, what should be the tag. So we are basically tagging our TechTalks producer with a Java tag, and the same thing for consumer. If we run the Docker compose build command, this is the context that we will be using. So this is under the src Java TechTalks producer folder. There is a file called as Docker file, which is the file used as the Docker file for building the producer, and same way for the consumer there is another Docker file. So this is the same Docker file we looked at a few minutes back. So the Docker compose is going to use both those Docker files to build and run the applications at the same time. So here we have the mount cache running now, the stage or the step in our producer build, and we can see that it is more than 140 seconds that it is running and it's downloading these dependencies. So let's see how much time does it take to download all the dependencies and then build the application. So finally, there we have it. It took us almost about 728 seconds, which is like more than 12 minutes to build one single TechTalks producer Docker image using the multi-stage build. That's hell lot of a time to build just one single image. Now we are going to switch over to Docker Compose and see if we get any benefit of using that mount cache, which we try to store our dependencies in. So I'm going to run this Docker Compose command by giving the file name as Docker Compose Java Docker Hub, and we are going to run the build command. This will try to build both the producer and consumer again, but since we have already built the producer, I assume that the way Docker works internally, it will not rebuild the producer, but it will just try to build the consumer, and it will also try to use the dependency cache. And hopefully this time to build the consumer, the time would be much less than 12 minutes. So we can see that it is already moving to the run stage where we run the package, which means that it has looked at the build cache and it is able to reference that build cache here. It is running for about 35 seconds. Let's see how much total time it takes. Actually, the number of dependencies in the consumer is much less compared to the producer, so my expectation is it should take less amount of time to build the consumer here, since all the dependencies are already cached. And looks like the process is over here. We were able to generate it in just about 2 minutes, 126 seconds. So that's a huge time saving as compared to running the producer, which was, or building the producer, which took about 12 to 13 minutes. We are able to do this under 3 minutes using the mount cache feature for caching the dependencies. Now, since we have the images, let's quickly see that the producer and consumer images are now tagged correctly for Java. We have one image which was built about 4 minutes ago, the TechTalks producer, and the consumer was built just 40 seconds ago. Now we can run these images using the Docker run command and see that it runs fine. So for the producer, let's go and run the Docker run command here on the terminal. I'm going to reference that TechTalks producer image which we generated just now, or which we built just now. And same way for the consumer, we will also run the consumer. So I run the Docker run command here. I want to have an interactive terminal. The name of that image or the container which will be generated is TechTalks producer. I'm mapping the port 8080 on the container to the host port of 8081, and the image we will use is Nilesh Gule TechTalks Producer with Java Tech. Let's go and run this, and we will do the same thing for the consumer as well. So we can see that when we run the docker run command for producer, the Spring Boot application has started, and it's giving us the log that we would usually see on our terminal if we run the Spring application on our local machine or local laptop. Same way, we should be able to see the consumer also coming up shortly. So here we can see that there is a message saying started TechTalks Producer application. It took about a minute to start. Usually it starts a bit faster, but looks like there is some issue with my laptop today. And same way for the consumer as well. We see that the consumer is starting, and almost in a minute it would take similar time to start the consumer as well. So let's switch over to the slides again and see what did we achieve. So we used a multi-stage Docker file to build our application or containerize our Spring Boot application using the Eclipse Temurin 17 JDK Alpine base image. We built the application code, and then we also used this mount type feature to cache the dependencies, and then we use that mount for the consumer build. So in summary, we use this Eclipse Temurin base image for JDK as well as JRE. So if I switch back again, we can see that we are using a different runtime image here, which is again based on Eclipse Temurin, but the tag is 17 JRE Alpine. So for building, we use the image with JDK, which contains all the build tools, but we don't need those tools for running the application. So we use the JRE image for running the application, and we use the separate stages for building and running. We also use this cache feature for caching the dependencies, which helped us to reduce the time drastically, where we saw the TechTalks Producer took about 13 minutes to build, and we were able to build the consumer in less than 3 minutes. And the last thing that I want to show is how to publish these images to Docker Hub. Earlier in this channel, I did a separate video for how to publish the images to Docker Hub using Docker Compose. So I'm going to use this same file which I have, or which I use for building the producer and consumer, and I can use the push command here. So when I use push, both the producer and consumer images with whatever tag we specified in the Docker Compose file will be pushed to the container registry, which in our case currently is Docker Hub. So here we can see that the image is being pushed, and if we go to the public Docker Hub registry, we should be able to see both our images with Java tag pushed there. So let's say Docker Hub, and let me log into this. Let's quickly verify that both our images, producer and consumer, are available or are published to Docker Hub. So if we go back to Docker Compose, we can see that some of these layers are getting pushed, and some layers they already exist. So here I have used Docker Compose with the same Docker Compose file to push the container images to Docker Hub. We can go to the Docker Hub and verify that those images are already available. You can in fact go back to the previous video and see how to do that. So let's go back to the slide and continue from there. So this video was part of the Cloud Native Ninja series. In case you would like to contribute to this series, head over to the GitHub repository, which is named as Cloud Native Ninja in my GitHub repo. The slides that were used for this session and the earlier sessions are published to SlideShare and SpeakerDAG. If you would like to contribute, please feel free. I'm more than happy to accept pull requests for this repository. Thanks for watching this video. I hope you like it. In case you found it useful, please hit the like button, subscribe to my channel, and until next time, code with passion and strive for excellence.